before entering the high pressure cylinder. The compression and expansion process follow a polytropic law for PV, power 1.28 equal to constant, and the clearance volume of each cylinder is 4% of the respective swept volume. Jadi in our case, we are looking at the case of whereby we have the Pi over P1 equal to P2 equal to Pi. This is not the same. Okay, they are not the same. Okay, and also we are getting that the T1 is not equal to the Ti prime. So the implication of these features that being asked from this question, if we have to determine the IP, then we need to determine one by one. We have to get what is IPLP, get what is IPHP, then we will add them up. That will be our total work input to the compressors. Okay. So as for the question, before that, let us look at our PV diagram. Okay, PV diagram. This is our pressure. This is our volume. We have 4 pressures as far as state 1 and state I and state 2 is concerned. Okay, so we are going to sketch these 3 pressure where this is our P1, this is our Pi, and this is our P2. And given every pressure in the question, okay, you can refer to the pressure given from the question. So this should be at 98. This is in kPa. This is at 98 kilopascal, and then we have 800 kilopascal, and then we have 4500. If you see the pressure ratio, P2 per Pi is 4500 divided by 800, and for the low pressure compressor is 800 divided by 98. And due to the same VC, okay, this is our VC, both having the same VC, which is a VC equal to 0.04, either for low pressure or the high pressure, they are the same. Okay, so let us look at our, this is our re-expansion process. This is our re-expansion process for the high pressure. This is our low pressure compression process. This is our high pressure compression process. This is our delivery of the low pressure process, low pressure compressor to the high pressure compressor, the second stage. This is the induction based on the free air delivery. This is the delivery of our compressed air. Okay, so this is our direction of process. And for the high pressure, this is our process, the direction of the process. Okay, and then this is A, this is B, this is C, and this is D. And for the high pressure, this is A prime, B prime, this is C prime, and this is D prime. Okay, so we have the induction of low pressure is VA minus VD, and the induction of the high pressure is VA prime minus VD prime. Right? Okay. Now the temperature, we need to look carefully each temperature for each state, because now we have how many states? 1, 2, 3, and 4. We have 4 states, which is the P and T. Oh, sorry, 1, 2, 3, 4, 5 states. Right? This is the state of PT, the free air delivery state. This is our end of the induction stroke for the low pressure compressor. This is the delivery of the low pressure compressor, which is PI and TI. And then after intercooling process, the PI maintain no pressure loss, but the TI will be lower compared to the TI prime. Okay. And then after that, we are going to have the P2, T2, which is our delivery state. Okay. So if we look to the question asks, the first question is asking for the sketch of the PV diagram. So we have sketched the PV diagram. This is our part 1. Okay. And then we are going to look at the second question. Determine the swept volume for each cylinder. So now we have 2 cylinders. One is the high pressure, another one is the low pressure. So we are going to name the swept volume right here. This is for the low pressure compressor. This is the high pressure compressor. Then we have written right here, we give the name for the low pressure as a VSL and the high pressure as a VSH. Okay, VSH. So in order to get the low pressure swept volume, then we need to know our VA minus VD. Okay, VA minus VD. So this is number 2. Always we get the VS from the induction stroke or from the induction condition. Right? So as far as the VA minus VD is concerned, then we need to get for per cycle. In order to get the VSL, so we need to get or to observe, to analyze the VA minus VD in term per cycle. So this is a VA dot minus VD dot divided by, to change from per minute, we change to per cycle, so we need to divide by the speed of the compressor. Okay. And then after that, we need to get what is VA minus VD in terms of value. So this is VA dot minus VD dot. We are going to get from the state 1, the end of the induction stroke. So this should be M dot R T1 divided by P1. And then we need to get what is our M dot. The M dot we could get from the free air delivery condition, which is equal to PV divided by RT. Okay. So based on this, sorry, this is V dot. Okay. We are given the V dot as 4.5. We are given the P 1.013, and the T is at our condition of free air delivery. So this is our free air delivery condition. Okay, everything is there. The P, the T, also the free air delivery. So in this case, we could solve for m dot, and we are going to have the m dot in terms of kilogram per second. So we are going to have 0.08824 kilogram per second. So once we have determined the m dot, then we could get what is V dot A minus V dot D. Okay, V dot A minus V dot D. So we put the values in this equation. Then we are going to get the V dot A minus V dot D, which is equal to 0.08088. This is in meter cube per second. Then we divide the V dot A and V dot D by the speed of the motor, the RPM. Then we are getting the VA minus VD, which is equal to 0.04853 meter cube per cycle. So we have converted it from second to per cycle. Then we need to put the VA minus VD in terms of VS. So of course, we have done that before for the single stage and for the double acting stage. What we do, what is VA minus VD? The VA is equal to the VS plus VC. And what is VD? VD is VC P2 over P, sorry. In this case, it's not P2. In this case, it's Pi divided by P1, 1 over N. Sorry, no, yeah, 1 over N. Okay. So we can substitute this as, okay, we are looking at the low pressure side or the low pressure compressor, then this should be L. Okay, and this is equal to 0.04 VSL. Same goes for this. This is given, the intermediate pressure, and the P1 is also given. Then we have the VA minus VD in terms of VS. So the VA minus VD in terms of VS is 0.8 0.8337 372 VSL. So we have this figure, equate this figure, then this will solve for VSL is equal to 0.054797 meter cube. Okay, that is for VSL. And then as for the VSH, we are going to use the same manner, the same method, the same steps, right? But what are we going to look right here is the VA minus VD prime. This is our VA minus VD, but for VSH, this is prime, this is prime. And this is equal to VA, sorry, we have the m dot, right? We have the m dot. So in this case, we are going to have the VA prime minus VD prime divided by N. Same manner. Then we need to solve for the V. This is prime. And we know that the VA prime minus VD prime is basically based on PI and TI. And the TI is TI prime. Alright, so we are going to have the VA minus VD dot prime prime. This is equal to M dot RTI prime. This is the condition which is delivered into our induction stroke or the induction condition of our high pressure compressor. So we divide by PI. The M dot is still the same as this because this is a steady flow. At any point of the process, we are going to have the M dot they are the same. There's no difference because this is a steady flow condition. So when we have all these values, right? Then we are going to have this VA dot prime minus VD dot prime as 0.01007 meter cube over second. Now we need to define the VA minus VD prime. kg per cycle, then we divide by the speed of the compressor. Then we are going to get it in terms of per cycle. And this will give us the value of 6.04 6.0420 exponential minus 3 meter cube over cycle. Right? And due to the difference pressure ratio, although the VC in terms of VS they are the same, but because of we are having different pressure ratio, then we need to get the new figure for VA prime minus VD prime. If we have the complete intercooling case, we have the same pressure ratio, then there will be the same value. Or VA minus VD in terms of VF is the same value. If you are not sure, are you going to get the same value or not, I will advise you to do it individually for 2 stages compression process. Okay, but right now we know that incomplete intercooling and different pressure ratio, then we have to reanalyze the VA minus VD prime differently. So what is a VA prime minus VD prime? Of course, what is VA prime from the PV diagram? This is our VSH plus the VC minus, okay, if we have different type of percentage of the VC, then we need to use the different percentage. Okay, so this is a VD prime. What is the pressure? The pressure is P2 divided by PI 1 over N. Sorry, the VD, this is VD, so this is not VD, this is VC. Okay, it should be VC. So this is our VC. And as usual, this is in terms of 0.04 VSH. Okay, VSH. This is 800, this is 4,500. Right? So we are going to have the VA minus VD prime is 0.88580 VSH. Okay, so this is our VA minus VD. Then what we are going to do is to equate these two equations, which are the equation of VA minus VD in terms of cycle, and then we are having the VA minus VD prime in the function of VSH. Then from here we are going to have the VSL. So let's say this is our first equation, this is our second equation, and then we are going to equate one equal to equal to 2, 1 is equal to 2. So we have VSH equal to 6.82095 exponential of minus 3 meter cube. The question might ask you to put the value of this in terms of what do you think the suitable unit of this type of equation or this type of figures? What do you think? What do you think that you will be asked to get? Because this is too small. This is not appropriate for engineering type of unit or prefix. So what do you think? Maybe you will be asked to get in terms of centimeter cube, or maybe you have to get in terms of liter. So make sure that you know how to convert from meter cube to centimeter cube or in liter, right? So just for exercise, try to put this in centimeter cube or maybe in liter. Same goes for the low pressure compressor. Okay? And then, is there any question? Any question, guys? Ingat kalau kita tak sure whether the same pressure ratio ataupun complete intercooling, you need to do like this. But if you are confident enough saying that the same pressure ratio and incomplete intercooling, this will have the same term, okay, no problem. You see, in this case, our case, we have different figures of VA minus VD. Yang low pressure, we get 8.83372, but for the high pressure, we are going to get 0.88580. So please, don't just make it easy. Assume same pressure ratio, and then you will miss the calculation. Then it is wrong. And then after that, what we are going to do is to get the IP. Okay, number 3, the IP. So the IP consists of the IP for high pressure and IP for the low pressure. So this is equal to IP low pressure plus IP for the high pressure. So what is the IP for the low pressure? The IP for low pressure is equal to N minus N minus 1, M dot R T minus T. Okay, can you guys let me know which T minus which T for the high, for the low pressure?
Pi minus T.
Ti minus T1. Okay, what is our Ti? Ti is equal to T1 Pi over P1 N minus 1 over N. Okay, everything is given, the Ti is given, the Pi is given, the P1 is given. Then we could get the PTI as 495.5 Kelvin. So once you have your Ti, then you could get your IP. Okay, we have solved the m dot before, and this will be IP will be, this is for the low pressure, equal to 21.13 kilowatt. Okay. Next is the IP for HP. Again, the same formula. IP HP is equal to N over N minus 1 M dot R. This is T minus T. Which T minus which T?
T2 minus Ti prime.
Yes, T2 minus Ti prime. And what is T2? T2 is equal to Ti P2 over Pi N minus 1 over N. Is this equation correct?
Ti prime, sir.
Okay, good. Okay, this should be the beginning of the compression process for high pressure compressor. That is, the condition is Ti prime after the intercooling process. This is normal or common mistake student will do during the test or exam. Okay, this Ti prime. So be careful. This is Ti prime, not Ti. Because Ti prime and Ti is different in this case. So from here, we are going to have the T2 as 464.0 Kelvin. Okay. And then after solving the T2, then we will get the IP as 16.90 kilowatt. All right. Then the total of IP, okay, just add it up. Okay. And the next question, number 4, is to get the question is asking, number 4, is to get the volumetric efficiency of the low pressure cylinder. Okay, number 4, sorry. Number 4 is to get the volumetric efficiency. Number 4 is to get the volumetric efficiency of the low pressure, which is equal to VA minus VD divided by VS multiplied by, what is it? Multiplied by which one? You give me the symbol of T and P.
T over T1.
T over T1 This one?
P1 would be
P1 over P. Okay, of course, you need to multiply by 100 because usually we are going to have in terms of percentage. This VA minus VD, this is our VA minus VD. Okay, because we are going to determine the volumetric efficiency for the low pressure, so this is VSL. Okay, everything is there. Then you will get the volumetric efficiency as volumetric efficiency as where is the volumetric efficiency? Okay, 77.31. If we have the T1 equal to T equal to T1, P1 equal to P, then we have this 83.372. The volumetric efficiency. So this always indicating the volumetric efficiency. If this is the case of P1 equal to P and T is equal to T1 or Ti. In this case, it's Ti. All right. Next is to get the mechanical efficiency. Okay, sorry, to get the power of the motor. Given in this question number 5, given the number 5, given the mechanical efficiency as 0.85, then we need to get what is the power of the motor. The power of the motor is equal to the IP, the total IP divided by the mechanical efficiency. Okay, I think it's very simple. And the next one is to get the indicated power. If the compressor or the compressed air is used or is being processed as a single stage. Okay, as a single stage. So for a single stage, then we need to redraw back our compressor. This is number 6. So we need to sketch back to have a better picture of the problem. Then we have to sketch back this condition. This is our P, T, same V. This is P1, T1. This is our P2, T2. How about the m dot? Does the m dot is the same as these two stages and the single stage? Pardon?
same.
Yeah, they are the same. Okay, because we need to get the same delivery or the FAD, the V dot. So if this is the case, what is the IP? The IP is equal to, this is for the single stage, is N over N minus 1 M dot RT. In this case is T2 minus T1. Everything is there. Okay, everything is there. Then you will get your power as 47.45. It should be larger than for a double stage. Okay. And the last part is asking for the comment Compare the indicated power you obtain in part 3 and 4. Okay, part 3 and 4. As a mechanical engineer, which compressor system will you install? Of course, you are going to install which one?
Multi-stage.
The multi-stage. Why? This is our power for the because we use less power when we are using multi-stage. But the operation a bit complicated, and also you will use as an engineer, you will pick the second option, or the multi-stage, because it's easier to maintain. If you have multi-function of one stage, then you just look at the problem of that stage. You don't need to refurbish or review all the system. Okay? So that's it that I want to show you for today. So next, let us look a bit on my website.
Doktor,
Yeah.
untuk soalan kedua tu kan, yang formula VA tolak VD tu, saya Doktor akal. Untuk kan VA tolak VD sama dengan VSL tambah VC tolak VC bracket P2 over P1 kan. Kalau
Merah, yang merah ni ke yang merah ke yang mana ni?
yang merah ni.
Yang ni okey.
Untuk yang minus VC bracket P2 over PI tu, dalam diagram dia refer dekat area mana tu?
This one. VA prime minus VD prime. Nampak tak?
Oh.
Because VA minus VD is for the first stage. This is dVA minus VD. For the second stage, the VA minus VD is the VA prime minus VD prime.
Oh, okay.
Always look at the end of induction stroke.
Oh.
Okay, kalau untuk yang first stage, second stage ni, high pressure ni, the ends on induction stroke adalah keadaan D prime A prime. Okay. Okay, I want to ask you why this question does not ask us to get the volumetric efficiency of the second stage. Why only first stage?
Calculated using FPD.
Because of the definition of our volumetric efficiency. The definition of volumetric efficiency is basically the amount of air delivered or air intake, measured at pre-air delivery. If you look right here, the one that is involving the intake of at pre-air delivery is only for the first stage. The second stage, we know that the VA minus VD, or the condition of going into the second stage or the high pressure, is PITI. PITI is not from the free air delivery or the free air condition. It is a condition after the compression from the low pressure. So that's why the question doesn't ask us for the second stage. If you calculate, you will find that the volumetric efficiency will be double. Okay, or it's too large. That's why they don't ask. And it suit with the definition, okay, it meet the definition of volumetric efficiency itself. Because we need to get the amount or the mass or the volume of the air intake measured at the P and T. Okay? And for your information or for your exercise, I would advise you to get the PISO and get the efficiency for isothermal. Okay? Be careful. The PISO for this low pressure is basically at T1. And the PISO for the second or the high pressure is Ti prime. Okay, let me put that a bit. Please buat latihan berkenaan dengan PISO. So what is our plus PISO? Okay, this PISO, we have two PISO again. The PISO for the low pressure and PISO for the high pressure. For the PISO, low pressure is equal to M dot RT ln what? Anyone remember? Which P divided by which P? Come on guys.
PI over P1.
PI over P1. The T? Which T?
P1.
P1. MRT ln P over P. Which T? High pressure. Which T? For high pressure, which T are we going to use to determine the
PI
pressure?
prime.
PI prime. This is P2 over P. Okay. And I think you can also look several. We have done this, right? At my web page, we have done 14.15.02, which we have done it today. And then you still have several more example. The example that I given to you before this is 18.19.02 is not here. 19.20.02 is not here. Okay. So you have 1, 2, 3, 4. 4 more exercises that you can try. And in this case, I given you in my web page given the question and answer. So kalau tak score, tak tahu nak cakap lah you all. Banyaklah latihan-latihan yang kita buat. Okay, so please refer to my web page. Look at the. You can also have several questions on the exam paper. I've given here 3 sets of exam paper. Then please look lah mana yang ada compressor tu cuba buat. Which one have the compressor? You can have a try.
Doktor,
Ya.
nak tanya kalau untuk yang higher kan, guna I prime lah. TI prime.
Kalau apa?
Kalau contoh nak cari higher punya ni.
Tengok kalau ada intercooler gunakan TI prime lah.
Kalau tak ada,
Kalau tak ada intercooler tengok apa yang masuk. Yang masuk straight kepada. Apa yang masuk? Kita ambil data yang masuk. Masuk ke compressor high pressure.
okay doktor.
Yang kita gunakan tadi samalah Yang masuk tu ialah TI prime dengan PI. Kalau dia punya TI prime tu, kalau complete intercooling, you akan dapati TI prime tu sama dengan T1. Betul tak? Kait?
Yes doktor.
Kan? Yang kalau complete intercooling, the TI prime will be equal to T1. Dalam kes kita ni tidak, dia tak sama. Okay? Right. So, apa yang saya nak buat sekarang ni, nak tengok sedikit lah berkenaan kita punya guide kita ni. This is our statement of plagiarism. So, you need to sign it up before kita start test nanti. Right, you have to sign it up. And then nampak sini, note, please attach this statement at the end of the test 1 answer script. So, you kena sekalikan dengan jawapan. This plagiarism, the statement of plagiarism and academic dishonesty. This is for our class lah. For 0304 test 1. Semua dah dapat kan? So, And then we are going to look a bit on the guideline. This is our guideline. Okay. Please read the guideline. This is SOP lah. Kita semua dah baca pun sebenarnya benda ni. Jadi cuma to recap back. Just to recap back. Please read everything. Right. This is your requirement of internet and your computer. And then this is what during the test. This is a closed book. Closed book test. So jangan buka lah ini nota. Okay. And then the most important thing is the timeline ni. So this is you have to submit in a PDF form. Jadi tadi saya tanya kan, tadi case tadi Zadatul dengan Muhammad Nur. Dia punya email dia gunakan Yahoo. So tak ada masalah kan, siapa yang guna Yahoo? Sebab saya tahu kalau Google Form dia kena gunakan Google account untuk submit. Yang case bagi Takif tu tadi saya lupa nak setkan case Takif tadi, saya lupa nak setkan saya punya Google Form tu sebagai saya terima orang yang luar daripada UTM ataupun other than UTM punya member lah. Okay. Jadi maknanya Google personal pun boleh terima. Okay. So this timeline is very important So nanti hari Sabtu at 9:15 I will email you all using the same email yang saya hantar pada you all untuk classes. Saya akan hantar you dia punya test question which is encrypted with password. And then pukul 10.30 kita akan start kita punya meeting Webex. Saya akan hantar nanti macam biasa hantar link untuk Webex. And then kita akan mula on 10.15 dan pada 10.15 ni saya akan ambil kita punya attendance. And at this time you need to switch on your video all the time lah. And then at 10:20 saya akan mula bagi password. Saya akan bagi password selalunya dalam kita punya chat box dan juga WhatsApp group. Saya akan bagi dua. WhatsApp group pun saya bagi kita punya password, dekat chat box pun saya bagikan password. And then you all open the document, make sure that you can open it and read it. Any question, okay, masa tu kita boleh discuss yang very general lah. And then kita akan start test pukul 10.30 and up with 10:30 saya akan bagikan you all dia punya notice kalau tinggal lagi 15 minit dan juga tinggal lagi 5 minit. And then saya akan bagi notice bila masa dah tamat. So bila masa tamat, you need to combine all the answer script plus the statement of plagiarism towards the end of your answer script and then convert to PDF. And jangan lupa, this is how you name your file. Okay, name your file. Then you need, for our case, for our for our class, we are going to use this. This is the submission. Kita gunakan Google Form. Yang ni saya offkan dia. That's why dia keluar macam ni sebab saya tak buka lagi untuk menerima responses. Sorry. Okay, so please read this guideline carefully. Anything, let me know. And then tengoklah apa yang kita boleh, kita akan solvekan problem yang timbul lah Ingat along the test, semua kena on video. And then sebelum test tu pada pukul 10.45 tu saya akan ambil attendance lah. How do I take the attendance? Macam ni lah saya akan ambil, you pegang you punya metric card. Okay, on video, of course, saya akan snapshot everybody. Ataupun saya akan ambil screenshot for everybody. That is the attendance punya method yang kita akan gunakan. Okay? Any question guys?
Doktor,
Ya.
kalau tak ada metric card sana?
Mana pergi metric cardnya? Awak ni tahu berapa lah.
Tak, sebab kita orang tak masuk campus lagi.
IC ke?
IC ada?
Guna IC lah.
Okay.
Etikat tinggal pula. Tinggal kat college ke?
Tak, kita orang belum dapat lagi. Sebab kita
Belum
orang
dapat
baru
eh?
masuk. Kita
Oh,
orang
kau,
dari intake.
you all ni, oh yang mana dari intake. Apa belajar
Ha.
belajar universiti tak masuk kampus? Apa ertinya belajar universiti?
Ya,
Tak syok lah kan? Orang nak belajar
bosan.
universiti lah. Nak glamour lah. Kesian bang. Tak apalah. Sabar je lah ya. Saya punya student ramai dah masuk lah. Especially yang final year student lah. Okay, let me take your attendance sekejap eh. Let me take your attendance first. Saya ambil link dia.
Rugi tak merasa lagi. Nasib
apa.
Pattaya.
Oh, nasib Pattaya mana? Dekat
Dekat
Riverside.
Mecca.
Huh? Dekat Riverside.
Dekat Riverside.
Dekat Riverside. Saya ada. Dia orang buka ni. A la carte dia orang buka sebelum puasa. So sebelum saya balik saya order dulu lah. Tapau je. Okay, chat box. Tiba mana Tiba? Ini senyap Tiba?
Ada je tadi.
Ada ke?
Ah.
Oh tak dengar. Sorry. Check all